Hello?
Hello.
All right. On this one right here, it says this is continuing the problems that we had from yesterday. We're going to go over one of these in detail, and then I'm going to assign you guys another one. Say Kathleen skates on a straight track, starts from rest at the starting line. T equals 0 for from 0 to t is less than equal to 12 seconds. So Kathleen's velocity k is measured in feet per second. So now that is very important, that information right there. So this is k is measured in feet per second. So what does that tell me right there if it's feet per second?
It's
Velocity, it's the rate. Very good. So that is the rate, so that's my velocity is differentiable and increasing. Okay, so that's good. So values at k of t at various times t are given for the above table. So let's see, use the data in the table to estimate Kaylee's acceleration at t equals 4. Now, this table is all of velocity, right?
Yeah.
Okay, so now the slope of the velocity is my acceleration, right? So that's what we're trying to get. We're trying to find the slope of velocity to get that. So let's go ahead and look. So it's going to be where t is equal to 4 seconds. So I know that I'm going to have show computations that lead you to your answer, indicate units of measure. So 4 is going to be between here and here, right?
Mm-hmm.
So can I just find the slope there?
Yeah.
Okay, so it's going to be, so that's going to be a of t, which is my acceleration, is equal to 10 minus 5 over 5 minus 3, which is going to give me positive 5 halves, and,
Meters per second.
okay, so it's going to be feet per second squared. Okay, because the acceleration is always second per second. That one was pretty straightforward, right? Okay, so now let's look at points on this one. The points on this one, so if I have the 5 over 2, that's 1 point, and if I have the feet per second, that's another point. So that's 2 points total there. All right, use the right Riemann sum with 4 subintervals indicated by the data in the table to approximate the integral from 0 to 12 k of t dt. Indicate units of measure. This approximation is this approximation overestimate, underestimate for the value of 0 to 12 kt dt? Explain your reasoning. So that means that we're going to find the right hand. So in the 4 integrals, let me go back. There we go. So let me erase. So I'm going to have my interval, 4 intervals, 0 to 3, 3 to 5, 5 to 8, and 8 to 12. Right? So I know that I'm going to have from 0 to, what is it? What did I say, 3?
Yes.
3 to 5, 5 to 8, and 8 to 12. There we go. So I have my intervals there. Okay, if you notice, it just says subintervals, right? So they're not going to be the same size, are they? So they're not going to be the same uniform length in between each one. So these are making rectangles, right? Riemann sum makes the rectangles. So my delta x is going to be how far is that, and if it's a right-hand side, it's going to be the value of at 3. It's going to be 3 at 5 and 8 at 12. So that's going to be the height of my rectangles. So I know I'm going to have from 0 to 12, okay, k of t dt is equal to, okay, so now what is delta x? What is my thickness for this first one?
3 minus 0.
3 minus 0, which is 3, times, what was f of 3? Or in this case, k of 3? 5? Plus, now what's the delta x on the next one? 2 times, what is k of 5? Plus delta x on the next one? 3. What's that, 20?
Yeah. That's 4 times.
Plus 4 times, so what was it at 12?
4.
4?
24. Oh, wait.
24, there we go. Okay, there's a reason why I wrote it all out like this. So if you write out your integral and you space this out, you're going to get that 1 point for this right here. So you get 1 point for showing this integral is equal to this. All right, and so on this right here, we do the math. We find all the values. So this was, so 15 plus, this is a non-calculator. So if you show your calculations, 20 plus 60 plus 52?
No, 96.
96. Oh my goodness, I am off today. 96. Which altogether, that's going to give me how much?
121.
So it's 191. And what are my units?
Feet.
Feet.
Square. Because it's integrals.
But what are we talking about here, though?
The area under the graph of the velocity, which is the distance which it goes.
Very good. Distance traveled. So if I take the integral of the velocity, that's going to be the area under the graph, which is going to be my total distance traveled. So this is my total distance traveled here. So it's not, yes, it is area under the graph, but it's representing the feet traveled. So whenever I'm doing that, yes, I'm finding the area under the graph, but it's representing the total feet traveled. Okay? So whenever I do that, so my original function, my s of t, is my distance. My first derivative is going to be my velocity, my v of t. My next derivative is acceleration, which is my a of t. Okay? All right, so we have this right here, and explain. So we have right here, now, indicated unit measurement. Here's my 1 point. So I have 1 point for my setup for my integral, 1 point for my 191 feet, and another point for explanation. Is this going to be an overestimate or an underestimate? Over.
Because
Okay.
right.
So, overestimate, underestimate. Okay, so I think it's on the previous one. Right here it says, starts from the differentiable and increasing. There we go. And increasing. So if I'm doing all the time, if I'm doing the right hand of an increasing, it's always going to be overestimating. So right hand on an increasing graph will always be overestimating.
Isn't it right if you say that like
Or if I just did like a sketch of my graph and I said, it's like 5, 10, 15, 20, 25, so 0, 0 was 0, right? Next one was
3, 5,
3,
5,
5. Next one was,
5,
next one was,
10, 8, 20, and then 12, 2, 4.
so if you're sketching it, draw your little like that. You can draw it to show diagrams and explain what it is that it is an overestimate. You could say see the graph. That would be another way to get that point. Yes.
So if I wrote like this, it's overestimation because like k of 3 is bigger than k of 0, k of 5 is bigger than k of...
Yeah,
like
on an increasing graph.
Okay.
And for this one, that's the reason why I went back and circled it. It said that the graph is increasing. Right? That was stated. So that right there could be already given to me because it's, or we could also look at it, right?
And do you get a point if you didn't do the first two right, but you got the reasoning right?
Yes.
Okay.
You could still get this 1 point right here, even if you didn't get these 2 points. Because it doesn't have to do with this data right here, does it? It doesn't have anything to do with this data. It just has to do with the graph. Is it going to be an overestimation or underestimation? Nate skates on the same track, starting 5 feet ahead of Kathleen at time t equals 0. Nathan's velocity in feet per second is given to you by this. Write but do not evaluate an expression involving the integral that give Nathan's distance from the starting line at time t equals 12. There's his velocity, right? And what are we trying to find?
Yeah.
Because it's this.
Yeah. Travel.
Okay, so distance travel. So I need to find the integral of that, right?
Yeah.
Now, so that's going to be the integral.
It's going to do this if he travels, like from starting at 5.
Okay, so starting at what?
5 feet.
5. Very good. Starting at 5. Why am I starting at 5?
Because he started 5 feet ahead.
He's 5 feet ahead. So he's 5 feet ahead on this one. So this is basically the distance would be like an S of 12 would equal to 5 plus the integral from 0 to 12. And there's, you could write the whole thing,
Or you can just write L of t.
or you could just write n of t, because that's what I put, n of t dt.
And do you need to substitute
Nope.
distance?
No. You could have just that because your n of t is stated right here. Or you could just go 5 plus integral 0 to 12 because they're starting at same time and ending at same time. He just has a head start. And then I put 150 over t plus 3 minus 50 e to the negative, does that say t?
Yeah.
Kind of wrote over it.
Yeah. The negative t.
Negative t dt.
Can I, for example, write instead of 5 plus? Can I write so like 5 feet is like 3 seconds on the.
No.
So I
No.
Can, no, I can write like integral from 3 to 12 instead.
3 to 12. No.
No.
No. Because you're starting at the same time. He's just starting 5 feet ahead.
So I just plus this.
Yeah, you're just adding, yeah, he's got a head start of 5 feet. But they're starting at the same time t equals 0. Okay, if his starting time was different, then I would have to. So if it was like, all right, I start it and 2 seconds later, the other guy could start. Like a staggered start time, that's when you do stuff like that. Okay, now there's one thing I want you guys to actually pay close attention to. This is going to be helpful on some of these questions. Now, there's a big debate over this. Okay, especially with the AP readers. Do that. If you have a long integral, put parentheses around it with your dt at the end. Okay?
Why is that?
Wait, but
Because in
so you can think that it's just integral of 150 over t.
yes, we see it.
But there's dt in there.
I know, we see it. But just so you, yeah. Yeah, it's standard, it's known, but like if you plug it in the calculator, and you do a numerical integration, so it automatically opens these up with dt at the end. One of those weird things. So just think about it. So whenever you have long integrals, add that, especially on this free response. Write an expression for Nathan's acceleration in terms of t. So now what do I have to do?
Find the second.
Find the what?
The second derivative.
Not second derivative.
Integral?
It's not second derivative.
I mean first one and then.
It's first derivative, right?
That's
Because
the
we're taking the derivative of the velocity, right? If I'm taking the derivative of the velocity, it is the velocity in the first place. So one derivative below that is going to be my acceleration. So my n of t was equal to, can you guys help me with that one? What's it say?
150.
Negative.
150 over,
T plus 3 minus 50 e to the negative t.
okay. All right, so we're going to take the derivative of this, and then I'm going to have to do, I'm going to move this up to the top. So I'm going to do all the steps here. So it's going to be 150, and that's t plus 3 to the negative 1, right? Minus 50 e to the negative t. That one's going to be easy.
I didn't move mine up, so that would be.
Yeah, as long as you end up with the same answer, because you could jump past all that. Yeah, so at this point, you could probably jump past all that, right? Especially something right here. So let's take a look. So the derivative of, let's talk about the power, right? It's a chain rule. So the derivative of the power is going to give me negative 1, right?
Yeah.
And then I subtract 1 from my exponent, which is going to give me negative 2, right? So it's going to be n quantity t equals negative 150, right? And then it's going to be t plus 3 to the negative 2 times, what is the derivative of the inside?
1.
Just 1, right? 1. There you go. All right.
Plus
Wait, isn't it n prime of t for the derivative? Not n of t. Oh, for that's come down.
Oh, you're right. You're right. Sorry. Thank you. Your notation.
And then that one's going to be just plus 50.
Yes. Then right here. So now the derivative of e to the t is just going to be e to the t, but this is a negative out there, so that negative comes up front. So it's going to be plus 50 e to the negative t. And then I'm going to rewrite it with the negative exponent. So this right here would be absolutely correct.
Okay.
This is absolutely correct. You don't have to do anything else from here. So sometimes when you guys actually try to simplify things, you screw it up. And they only take your final answer. If it's correct to here, okay, you could leave it alone. So like that. But I'm going to simplify it so you could actually see what the simplified answer would be also. So I would stop right here. And this gets you 2 points.
Wait, so can I ask, what if I found the first derivative and then I don't know why, but I found the second derivative?
Then your answer would be wrong.
That would be wrong, even though I have it like in the first line?
No, yes, your answer would be wrong. It goes by your final answer. So if I rewrite this to show, so n prime of t is equal to negative 150 over t plus 3 to the positive 2 plus 50 e to the negative t. So if you did simplify it down to that, great. Okay, that's what you ended up getting, right? Okay. But like I said, if you left it at that, you would be fine.
Then how many points for the one above it, or C?
Huh?
C, how many points?
Oh, C? Did I not put points there? C was 2 points. So this right here will give me 2 points. So even if you would have did that one right there, still 2 points. And the only reason why I was able to say n of t on this one, because it was stated up here. You state n of t is equal to this. Alright, so I'm going to leave off here. Okay, don't forget, like, share, and subscribe. We're going to work on the next problem. Next problem is going to be 4.